And, and I now hand off the floor to Shireen Dooling, science communicator. Thank you so much today for joining us, Shireen.
Yes, thank you for having me. Let me get my screen up here. Let me know, can you see my presentation? Awesome. So again, thank you for having me. My name is Shireen Dooling. I'm a graphic designer, science illustrator. I'm really trying to hone in on creating a portfolio full of science illustrations, specifically infographics, and communicating science visually through like data visualization in the form of infographics. So a quick agenda about what we're going to be going over today. My background, why am I doing what I'm doing, and why do I feel like I have the position to speak on it today? What is science communication? Why is it important? And then a majority of this presentation, it will be a bunch of my past work, so examples of science visual communication, and then the context behind them. And I hope that when I go over these, they maybe inspire some questions that you can feel free to ask at the end of the presentation. And at the end, I'm going to do a short little takeaway. So my background, I actually ended up in fashion design when I started out from college. I did an associate's in fashion design, did a few B-level New York Fashion Weeks, and was hoping that my bachelor's in graphic design would help elevate and propel me into the fashion industry. Realized I was more in love with research and science. So I ended up back at Arizona State University in a full-time position and decided to take advantage of taking classes in a subject that I was really in love with and wanted to explore more, which is astrophysics. And in May, I will actually be graduating with a bachelor's in astrophysics. And the hope for my future career, which the Brooke Owens Fellowship is propelling me to do, which I am now currently one of their fellows for 2023. I want to both bridge the gap between science communication and visual communication, and understanding the research behind it to visually communicate researchers' research, and all the new findings, and when relating that to the space industry, making sure that the public knows why we are exploring space. So the bigger picture, and being able to visually communicate that to the public and to the masses in an easy, accessible manner is so important. And that's what I'm trying to do with my career. The Brooke Owens Fellowship, I highly recommend it. If there's any undergrads on this call, please apply to this fellowship. It is absolutely life-changing. They have actually matched me with NASA Goddard Space Flight Center. I'll be doing my internship there over the summer, and working on the largest science communications team in the world. They're a team of over 100. Their lab is split into data visualization and conceptual image visualization. So I'm so grateful for the Brooke Owens Fellowship. I cannot boast about them enough. And they're helping me figure out exactly where I fit in this realm of, graphic design meets science. So I'm completely grateful to them. So moving on, what is science communication? I think we all on this call know what science is and communicating it, but the nitty-gritty about it, like, it informs a viewer of your information. It educates a viewer of your research. It also raises awareness to new topics that not only the public should know about, but your other fellow researchers might want to know about and maybe possibly collaborate with you on. And it also inspires future generations. So, for example, science communication comes in many forms. It can be your influencers like Emily, the Space Gal, on Twitter and TikTok, where she's showing science experiments for little kids, inspiring them to be interested in the world of science and pique their curiosity. I mean, she's got a whole book, a new book on her experiments that's just about raising kids' curiosity in the fields of science. And then I'm sure a lot of you know Bill Nye the Science Guy, PBS, definitely in the realm of science communication. But it can also be as in the field of research and science, instructions for how to deal with samples. For example, this instruction packing instruction piece here is about how to pack COVID saliva samples that ASU was dealing with during the pandemic. But it can also be infographics like the New York Times map here, where it's digital media showing the different, heat indexes over a 100-year range. So a wide range of topics fit into science communication. And it just depends like which field or which form you would like to take to share your research or your knowledge with the public. Another form of science communication can be really, this is like the really nitty-gritty about it. So a typeface, for example, or a font. Futura is the font that NASA used on the plaque that was left on the moon from Apollo 11. And when you think about science communication, most people would think large picture. Maybe it's a header on your story that's going out on Eureka Alert, or it's, again, the New York Times infographic in a research article. But it can be as minute as selecting a typeface to go on a plaque that ends up being left on another celestial body in our solar system. So Futura, when it came into the industry, the design industry, it ended up being used for textbooks, newspapers, fine print, and encyclopedias. This created a air of being factual. If you saw this typeface, you knew the information written from it was authoritative. It carried a certain weight of being accurate and stating facts. So just keep in mind, like, there's the big picture and then there's the really tiny bits of pieces that make the big picture. And you have to think about all of it at the same time. Again, why is it important? So you really want to make sure science communication helps easily access information that is hard to grasp. So your abstract concepts, something that may not have ever been seen before. You want to make sure that your audience, whether that be public facing or, your fellow researchers in the field, or a field that you can collaborate with, can understand what your research is, why you're doing it, why it's important, why it will help contribute to society. And you want that to be quickly understood, especially in today's day and age where everything is like really fast turning information. The news is always something different every 5 minutes. And if you're utilizing social media, you definitely want that to be something that can be accessed quickly so you can, gain the audience that you need, and also increase public awareness and why we're doing what we're doing in the field of, science. Now I'm going to show you several different examples of my work from Arizona State University, and I'll explain a little bit about like the concept behind them, why I did what I did, and kind of the category it can fall under when we're talking about the science communication and infographics. So these are two covers I created for science journals. The first being Cell, This was more of meshing the abstract topic of research with a visual that was very well known. So this is an RNA, excuse me, an RNA based structure that would hone in on a malfunctioning piece of the RNA. So the professor or the researcher actually named their instrument SNIPER. That was the acronym for their structure. And so I wanted to make sure that when we saw the cover, that both the abstract was connected to the actual visual. So there was like a little bit of art involved in this, as well as being accurate to the information. And that's what you get with that cell cover. And again, the environmental science and technology cover, this was more of a public piece. So the information was supposed to be prevalent for what am I thinking of? Like real estate agents that own like large company buildings, knowing that Legionnaires can exist in water pipes and that it can be an issue. So a very public-facing and public-facing audience was something that this image was geared towards. You know, it's a shower head. This could end up in apartments, something that the public needed to be made aware of as well. So we had several audiences in mind with that image, and we wanted to invoke, you know, public-facing information and importance. So we used a shower head, which everyone publicly, you know, can relate to. This example is a little more detailed. So I was working with a researcher, Hao Yan, at Arizona State University, who works on DNA origami. That's what it's called. So his structures, these DNA origami, are little folded proteins that can attach to specific molecules in your body and help break them down. So like cancer. So a certain structure of DNA origami will connect to certain types of cancers. And once they connect, they can then break down that cell, that cancerous cell. He was inspired by diatoms. So diatoms are these tiny little structures in the ocean, and they are basically the building blocks of life, because everything, the food chain basically starts with diatoms. And so I wanted to make sure that when I was designing for him, that we were pulling his inspiration in with what his structures were. So making sure that, you know, biomimicry was actually captured. And then to take it another step further, we added a scale into this image to really make sure that, you know, the data visualization was there, and that you can tell 30 microns for a diatom is not nearly as small as like what his structures are. So just bringing that into a context here in this piece. And some of my work is also, it can get text heavy. This is an example of a text heavy visualization where a lot of things were happening in this piece, but making sure as the visualizer that only if you can't visualize it and you need words to go on here, to go on your visual, make sure that it is the absolutely necessary amount of words and no more. So this is a concept that you usually don't see in visual communications, just because it is a little text heavy, but I did want to put it on here as visual communicators, we are thinking about the researcher's needs. This was absolutely something that the researcher wanted to have spelled out as well as shown on the image. So just we take that into consideration too when designing. I've done everything from like battling misinformation for the vaccines and COVID. And this is another example that ASU had put out. We wanted to make sure that not only was it graphically represented, but it was also spelled out, especially when you're dealing with a topic as controversial as misinformation, and being as accurate as possible to the public, since this was a public facing piece, leaving no room for that misinterpretation of your information. And also want to point out that the visual for the person being shown is, gender ambiguous. Like, you're not being specific when you're trying to be as inclusive as possible when you're showing a person there. Just keeping all those little pieces in mind when designing for science is very important. Another piece that was actually picked up by one of the, I believe it's NIH, or no, National Science Foundation, NSF. They actually put this in their gallery for the concept of this far red light research that was done at ASU. And it's basically, it's really cool. There are these bacteria that can actually absorb light after the light left over after filtering through leaves above. So just trying to incorporate that concept in a visual with the least amount of words possible was the goal here. We did end up having a little more text than wanted, but again, the researcher wanted to make sure that when somebody was viewing this graphic, there was enough information on here for them not to have to read the paper, which is great because, like I said, you want your audience to visually pick up the information quickly. And if that does need words, a few extra words than just visuals, then absolutely we have to, go that route. This is more of the abstract being shown. So a protein in the brain, this is related to Alzheimer's work. There's a protein in the brain that actually ends up causing both tangles and plaques. And we didn't want to illustrate the protein at the time. We just wanted to illustrate the fact that this protein is connected to two separate issues that develops Alzheimer's in the brain. And that's kind of the concept we went with here. Again, this one is one of my favorite ones. And this is like the micro versus macro amount of information. The topic was basically just viruses. We had a researcher that was exploring viruses in Antarctica, and we wanted to show the sheer amount of information a virus or the viruses on Earth actually hold. And it is, as you can see, an astronomical amount of information. And I thought this was a really good example for science communication to the public, because now you're taking the small scale information that people probably don't even think about at all in a day. At least the public doesn't. But making that connection to, I mean, most everybody looks up at the night sky. So, making that connection to their environment around them, and also giving context with your light years from Earth. Again, we can't just say the Pleiades cluster and think somebody's going to understand that. Giving a 250 million light years amount to grasp is also too much for the general public to grasp. So then breaking that up into like the nearest star is 4.4 light years away. That helps, give context to the amount of information that's encompassed in these viruses and being shown in this graphic. here's an example of data visualization that we did for some plastics and microplastics information that was coming out of ASU a couple years ago. So showing, the amount of people, like that one in, I believe it's 1 in 5 or 1 in 4, I can't see. 1 in 5 people will flush their contacts down the sink or the toilet. And, making that data visualization connection here, it was important, but also showing the amount of information, the amount of trash that was created, 45,000 pounds. For the public, that might mean that's too big of a number for the public to grasp. So creating that connection to the fighter jet, the weight of a fighter jet really helps, bridge that gap of what that means in context of an everyday person and why they should care about it. Because this was definitely public facing campaign, trying to get people not to flush their contacts or not to, dispose their contacts in waterways, and also helping them realize, like, if this was recycled, what could you do? Like, what could we have eliminated from, the trash or the landfills? Just giving that context to the public is a very important thing when designing for science. This is more of a pathways distribution of how microplastics gets from your house, again, a public facing campaign, how microplastics get from your house into the environment. And that happens anyway from your house to even your food. For example, the fishing nets on boats, they end up fraying and ending up in food sources and in the environment. But also we had another another number aspect here in this graphic that we wanted to make more digestible by comparing that to the Grand Canyon, something that the public can, understand and digest. I've also done infographics that have more of a textbook approach. This one was based on information about volcanoes. This is Mount St. Helens. I wanted to make sure that the concept illustrated on the left was actually brought into light by showing that actual image of Mount St. Helens on the right. So just small things to make your visual communication and your science communication seem relatable. We're using illustration juxtaposed to, real visuals. Again, this was also part of the another piece that accompanied that story, just showing the different elements that come out of volcanic ash. We were trying to make sure that we weren't saying, like, volcanic ash is terrible, because volcanic ash can help fertilize the surrounding areas for crops and new plants and stuff like that. We also added, the volcanoes in the solar system as a little added fun bonus. Again, most of these pieces are for public outreach. So we were trying to definitely help, raise awareness as well as educate our audience on the different volcanoes, not only on Earth, but in our solar systems as well. So what is similar and different between science illustration and graphic design? I would like to say that the similarities is like the fact that you have to do research on your subject matter. It doesn't matter what you're making, you're always going to have some form of research go into that. But the extent of research that you have to conduct when designing for science communication is so much more in depth. You have to be able to communicate with your researcher or your scientist. You have to make sure you understand what's being published and what those important key takeaways are that the researcher wants you to project to their audience, whether that is, fellow scientists and researchers, maybe it's companies that they hope to partner with, or the public as well. Maybe this is a public facing campaign. Making sure that you can create their research in easily accessible visuals accurately is so important. And it does take a lot of research to do that correctly. For example, this was a graphic set that accompanied different variants that ASU had been researching for during COVID. And the extent of research for these graphics was very in-depth. Not only did we do a map of where each variant was first tracked, but we also wanted to make sure that we were showing like where the mutations were on a certain spike and how many different levels were involved from one variant to the next on each spike. So this was a very, very research heavy visualization set. And it definitely was both for further research and further research collaboration, as well as public facing awareness. And then I just want to touch on like the challenges faced as a science illustrator. It's definitely about understanding the material. Sometimes I get topics that are so abstract, or concepts of proteins that are so small that it's hard to really understand where to start. So that just means, asking the right questions, asking enough questions, making sure you understand, again, that researcher's audience, or the audience of this campaign. But also like designing for something that has never been seen before is also a challenge. Maybe for example, maybe there isn't an image of this protein or the interaction this protein has, but you want to somehow visually communicate that this interaction between these two proteins happens, and therefore, something bad can happen. So those are definitely the challenges. However, asking enough questions, and as a science illustrator, asking enough questions, but as the researcher, making sure that you're communicating to a science illustrator exactly what it is that you hope to accomplish with this visual is extremely important in that collaboration process of creating this new science communication visualization for your research. Again, this was a topic and a graphic for a topic that nobody had actually ever seen. It was about these fuel reservoirs that they surround galaxies on the outermost areas of the galaxy, not even like the end of your spiral, for example, but like farther out. And they have this astronomer found that those leftover fuel reservoirs were probably what fueled the start of star formations in galaxies. And again, she did not actually have a visualization for this. This was definitely a back and forth process. I actually started with the clouds much closer, and then she let me know that they were farther out. I thought it was a surrounded swirl, and she said, no, they were more like puffs. And so it was very much a very well done collaborated effort to create this graphic. But again, neither one of us had actually seen what this would look like. She only knew because of her data collection, and I was just creating based on, what I thought a cloud looked like. So very much a challenge here, but I thought this was a graphic that turned out very well with that collaboration effort. Again, another never before seen concept that was illustrated that ended up being pretty accurate to, theoretical compositions was the interstellar black hole image. Again, another concept illustrating for something that had never been seen before. and at the time was a very abstract concept. Another topic I want to touch on is true to the subject scientifically versus, an artistic license to keep your audience interested. Like, at what point do you want to make sure that your visual communication is scientifically accurate versus, taking the route of being more artistic? I think that has to do with the audience you're working with, definitely. Is this just a header for a story that you need something eye-catching to bring the public in? Or is this an image that you want to use to raise public awareness of some information that the public needs to actually take action on? So accuracy is expected in those situations if it is an action item. However, if you're just doing a header that's eye-catching, you can take more of that artistic license to make it more on the artistic representation versus, scientific accuracy. And these are two images that I think display that concept very well. Again, this was the visualization that I'd shown for DNA origami with Hao Yan at ASU. Mine was more of the scientific representation of what his structures look like. Those are actually what his structures look like. Biomimic representation shown as well with the diatoms. However, for the same article or the same topic that was written for Fast Company, they had an artist draw this rendition, which was very much the artistic representation of what his structures look like. So just showing that difference of audiences and when you want to use one versus the other is important to think of when you want to come to a science illustrator and have them help visualize your research and your topic. If there is anyone in the audience that is thinking about, the skills needed to work in graphic design, it's definitely patience, discipline, and perseverance. These are, if you have these skills, you can work in graphic design, because every other skill needed for graphic design can be learned. And then additional training required to become a science illustrator definitely depends on the type you want to be. There are, on the next slide, I'll show you a few examples of that. And then the Adobe Creative Suite core programs, cannot recommend those enough. Those are industry standard. And if you learn one, you can definitely notice that learning the next or the other programs within that suite are much easier. So that is your core skill set for software. Also, 3D rendering programs are a major plus on Java applications. I will say Blender is completely free and has great tutorials on YouTube. So if you wanted to start there, it's what I use. Definitely look into that. Having that 3D rendering capability, especially in the biology field, is very important, because a lot of proteins are rendered in 3D areas versus flat 2D designs. And then learning how to research, that is probably the most important training and skill for science illustration. Because if you don't know how to research your topic that is abstract and you don't know how to ask the right questions, it's a lot harder to end up at that final piece that's displaying your information scientifically accurately. But going back to the different kinds of science illustrations, anything from like natural history illustration, which is basically it can be anything from sketching to watercolors to pencil colors of the world around you. And that is usually a really big thing when working with museums and like in taking different artifacts. A lot of the people will sketch them to scientific accuracy. So just making those delicate, natural looking images of the piece that's in front of you. And then there's medical illustration, which is basically the most accurate form of science illustration. You have to make sure what you're drawing in medical illustration is as accurate as possible, because these are going in textbooks usually to teach other students and other professionals about anatomy and everything in the medical field. And then there's 3D rendering illustration. Like I said before, it's a huge plus right now in the science illustration and the biology world, especially. But yeah, those are the 3 most prominent forms of science illustration. And then going forward, when to incorporate science communication. I think these are the most important topics if you're thinking about, how to communicate your information. You need to understand the audience you want to inform, and make sure you relay that to your science illustrator. Is your research educational? If it's educational, definitely try to incorporate science communication into your research. And does it raise awareness to the public or for funding? That is a great time to bring in a science communicator for your research and trying to visualize what it is you're doing, because an image will capture your audience a lot faster than, a text heavy abstract. And then also, is your research something you want to bring the next generation into? Do you want to inspire new scientists? Do you want to inspire new undergrads? Are you trying to get more people in a field that you've noticed is a niche? If there was the answer to yes to any of those questions, then definitely look into science communication for your research. And other than that, that was my talk. You can follow me for space facts and science illustrations on both Instagram and Twitter. I'd love to hear any questions that you have. I know I gave you a ton of actual work, so I hope it, kind of help facilitate some questions that you might have. Thank you.
Thank you so much. One of the questions I have, and I hate to steal the floor, but I'll start because it may be a question many people have, is so I am hopeless graphically. I'm hopeless visually. Shilpi Ganguly does all of our amazing PR, and everything she makes looks beautiful, gorgeous, outstanding. I can't even begin to think about how she might have thought about making it, which is interesting because I'm a writer, and I could write, if you want to understand how much DNA is in a virus, consider expanding it all the way to, this star cluster, which would actually take you 235 years to get to if you're going the speed of light. Then you'll be in the right ballpark. I could write that sentence easily, and I've written sentences like it, but I would never be able to draw it. How do I go about locating somebody who can assist me with the graphics? If I'm doing a story or an event or something else, do you all have a location you hang out? Can I contact the pool of amazing science graphic designers and say, hey, I need some assistance with this? How does it work?
That's a great question. I actually have found that what I'm getting into is such a small majority of the graphic designers out there that it is a little hard to find that person to work with. I would recommend, however, that any large institution, let's say Mayo Clinic, for example, they have a marketing team, and say you're working within the Mayo Clinic, and you have some research that you'd like to illustrate. Make sure that you look up that marketing team, because they could definitely either have a science illustrator on their team or put you in connection to possibly one of their freelancers. So just I know it's a little bit of a hunting game, but at this time, because it is a niche field, I think that's kind of where everyone has to start out. But yeah, that's what I would recommend. Also, universities. If you're not associated or your company doesn't have a marketing team, or you're at a university, on a research lab or something like that, definitely reach out to your university's overall marketing team. They can sometimes point you in the right direction, or have a contact list of freelance designers. If your institute, or if your university has an institute, like ASU does have a biodesign institute, which is where I work, which is they had to have a science illustrator on their team. So you can look for those kinds of contacts as well through universities. Otherwise, maybe key search on LinkedIn. I've tried to do that. I have gotten a few inquiries through that keyword search, but again, it is a very niche field, which I wish it wasn't. I think this is a very important topic going forward in our society, especially in the day and age of misinformation and where facts are being, constantly rebutted for whatever reason. So making sure you have that network of people that can help communicate your science to the different audiences is going to be so important. And unfortunately, it is a bit of a hide and seek right now to find those right